Hello and welcome back. So, is our planet Earth round or flat? First, what is Earth? Earth is our home planet. Scientists believe that Earth and its moon was formed around the same time as the rest of the solar system. They think that was about 4.5 billion years ago. Earth is the fifth largest planet in the solar system. Its diameter is about 8,000 miles, and Earth is the third closest planet to the Sun. Its average distance from the Sun is about 93 million miles, and only Mercury and Venus are closer. On Earth, everything is just about right for life to exist. It's warm, but not too warm, and it has water, but not too much water. And Earth is the only planet known to have large amount of liquid water. Liquid water is essential for life, and Earth is the only planet where life is known to exist. Now, what does Earth look like? Based on the description of nasa.gov, from space, Earth looks like a blue marble, with white swirls and areas of brown, yellow, green, and white. The blue is water, which covers about 71% of Earth's surface. The white swirls are clouds. The areas of brown, yellow, and green are land. And the areas of white are ice and snow. The equator is an imaginary circle that divides Earth into two halves. The northern half is called the northern hemisphere, and the southern half is called the southern hemisphere. The northernmost point on Earth is called the North Pole, and the southernmost point on Earth is called the South Pole. So, is the planet Earth round or flat? The explanation is coming up right now. Now, some people still wrongly believe that the Earth is flat. The flat Earth model is an archaic conception of Earth shaped as a plane or disk. Many ancient cultures subscribed to a flat Earth cosmography, including Greece until the classical period of 323 BC, the Bronze Age and Iron Age civilizations of the Near East until the Hellenistic period of 31 BC, India until the Gupta period, and China until the 17th century. The idea of a spherical Earth appeared in ancient Greek philosophy with Pythagoras in the 6th century BC, although most pre-Socratics retain the flat Earth model. In the early 4th century BC, Plato wrote about a spherical Earth, and by about 330 BC, his former student Aristotle has provided strong empirical evidence for this. Knowledge of the Earth's global shape then gradually began to spread around the world. Despite the scientific fact of Earth's sphericity, many flat Earth conspiracy theories are espoused by modern flat Earth societies and increasingly by unaffiliated individuals using social media. In early Egyptian and Mesopotamian thought, the world was portrayed as a disk floating in the ocean. The Israelites also imagined the Earth to be a disk floating on water with an arc firmament above it that separates the Earth from the heavens. Several pre-Socratic philosophers believed that the world was flat. Belief in a flat Earth continued into the 5th century before BC. The ancient Germanic peoples believed that a flat Earth cosmography with the Earth surrounded by an ocean. In ancient China, the prevailing belief was that the Earth was a flat and square, while the heavens were round. Now, Pythagoras in the 6th century BC stated that the Earth is spherical, and this view spread rapidly in the Greek world. Around 330 BC, Aristotle maintained on the basis of physical theory and observational evidence that the Earth was spherical and reported an estimate of its circumference. By the 2nd century AD, Ptolemy has derived the maps from a globe and developed the system of latitude, longitude, and climes. His Almagest was written in Greek and only translated into Latin in the 11th century from Arabic translations. One of the ultimate demonstrations came when Ferdinand Magellan's expedition completed the first global circumnavigation in 1521. Antonio Pigafetta, one of the few survivors of the voyage, recorded the loss of a day in the course of the voyage, giving evidence for east-west curvature. The Abbasid Caliphate saw a great flowering of astronomy and mathematics in the 9th century AD. Muslim scholars of the past believed in a spherical earth. In the 17th century, the idea of a spherical earth spread in China due to the influence of the Jesuits, who held high positions as astronomers at the imperial court. So, well before Columbus sailed the ocean, Aristotle and other ancient Greek scholars proposed that the earth was round. This was based on a number of observations, such as the fact that departing ships not only appear smaller as they sail away, but also seem to sink in the horizon, as one might expect if sailing across a bowl, says geographer Bill Carson of Virginia Tech. Isaac Newton first proposed that the earth was not perfectly round. Instead, he suggested that it was a spheroid, a sphere that is squashed at its poles and swirling at the equator. He was correct, and because of this, the distance from Earth's surface to sea level is roughly 21 kilometers or 13 miles greater at the equator than at the poles. Earth's shape also changes over time due to other dynamics factors. Now, a lot of mass shifts around inside the planet, altering those gravitational anomalies. Mountains and valleys emerge and disappear due to plate tectonics, and the gravitational pull of the moon and the sun not only cause ocean and atmospheric tides, but earth tides as well. So, the simplest model for the shape of the entire earth is a sphere. The earth's radius is the distance from Earth's center to its surface is about 6,371 kilometers or 3,959 miles. Now, how do we know that our planet Earth is round? Humans have known that Earth is round for more than 2,000 years. The ancient Greeks measured shadows during summer solstice and also calculated Earth's circumference. They used positions of stars and constellations to estimate distances on Earth. They could even see the planet's round shadow on the moon during a lunar eclipse. We can still see this in our time. During lunar eclipses, if you see the shape of Earth's shadow on the moon, it is always round. If Earth were flat, sometimes you would get a flat shadow, and we have never seen a flat shadow during lunar eclipses. We always see an arc of a circle no matter the orientation of the sun and the moon. And the only thing that makes a perfectly circular shadow is a sphere. And today, scientists use geodesy, which is the science of measuring Earth's shapes, gravity, and rotation. Geodesy provides accurate measurements that show Earth is round. With GPS and satellites, scientists can measure Earth's size and shape to within a centimeter. Pictures from space also show Earth is round like the moon. Even though our planet is a sphere, it is not a perfect sphere. Because of the force caused when Earth rotates, the North and South Pole are slightly a little bit flat. Earth's rotation, wobbly motion, and other forces are making the planet change shape very slowly, but it is still round. Now, how does our planet Earth move? Our planet Earth orbits the sun once every 365 days or once every year. The shape of the orbits of the Earth is not quite a perfect circle. It's more like an oval, which causes Earth's distance from the Sun to vary during the year. Earth is nearest to the Sun in January, when it's about 91 million miles away, and Earth is farthest from the Sun in July, when it's about 95 million miles away. At the equator, Earth spins at just over 1,000 miles per hour. Earth makes a full spin around its axis once every 24 hours or once per day. The axis is just an imaginary line throughout the center of the planet from the North Pole to the South Pole, rather than straight up and down. Earth's axis tilted at an angle of 23.5 degrees. Now, why do we have days and nights? At all times, half of the Earth is lighted by the Sun and half is in the darkness. Areas facing toward the Sun experience daytime, and areas facing away from the Sun experience nighttime. As the planet spins, most places on Earth cycle through day and night once every 24 hours. The North Pole and South Pole have continuous daylight or darkness depending on the time of the year. Now, why does our planet Earth have seasons? Earth has seasons because its axis is tilted. Thus, the sun's rays hit different parts of the planet more directly depending on the time of the year. So, from June to August, the sun rays hit the northern hemisphere more directly than the southern hemisphere. The result is warm or summer weather in the northern hemisphere and cold or winter weather in the southern hemisphere. And from December to February, the sun rays hit the northern hemisphere less directly than the southern hemisphere. And the result is cold or winter weather in the northern hemisphere and warm or summer weather in the southern hemisphere. And from September to November, the sun shines equally on both hemispheres. The result is fall in the northern hemisphere and spring in the southern hemisphere. The sun also shines equally on both hemispheres from March to May, and the result is spring in the northern hemisphere and fall in the southern hemisphere. Now, what are our planet Earth's different parts? Earth consists of land, air, water, and life. The land contains mountains, valleys, and flat areas. The air is made up of different gases, mainly nitrogen and oxygen. The water includes oceans, lakes, rivers, streams, rain, snow, and ice. Life consists of people, animals, and plants. There are millions of species or kinds of life on Earth. Their sizes range from very tiny to very large. Below the Earth's surface are layers of rock and metals. Temperatures increase with depth all the way to about 12,000 degrees Fahrenheit at Earth's inner core. Our planet Earth's part was seen as largely separate from each other, but now they are all viewed as one ecosystem called the Earth system. Earth parts connect to and affect each of the other parts. For example, the clouds in the air drop rain and snow on land. The water gives life to humans, animals, and plants. The volcanoes on land send gas and dust into the air, and people breathe air and drink water. So, the Earth system science is the study of interactions between and among Earth's different parts. You can learn more about our planet Earth at nasa.gov or at scientificamerican.com or anywhere online. All right, guys, thank you so much for watching, and we will see you in the next video.